For billions of years, our galaxy may have been spinning in one direction. Then a colossal collision may have knocked its growing disk almost sideways. A possible 90-degree flip is one of the strangest clues hidden in the motions of the Milky Way's oldest stars. Before the mystery goes too far, the Milky Way flipped needs translating. A galaxy is not a solid dinner plate that can physically tip over in empty space. It is a vast, rotating system of stars, gas, dust, and dark matter. What researchers mean is that the direction of the galaxy's angular momentum, its overall spin axis, may have changed dramatically. The early stellar disk could have rotated in a plane nearly perpendicular to the disk we live in today. This is not a direct photograph of a sideways Milky Way. No telescope can look 10 billion years into our galaxy's past and take a snapshot. It is a reconstruction, built from stellar archaeology. Astronomers use the European Space Agency's Gaia mission, which has precisely measured the positions and motions of more than 1 billion stars. Add chemical fingerprints, especially a star's amount of elements heavier than helium, and scientists can sort stars that formed in the Milky Way from stars captured when smaller galaxies crashed into it. The prime suspect is a long-vanished dwarf galaxy called Gaia Sausage Enceladus. Gaia data revealed many halo stars moving on highly elongated back-and-forth orbits rather than calmly circling in the Milky Way's disk. Their velocity pattern resembles a sausage in certain plots, hence the unusual name. Their chemistry also distinguishes them from most native disk stars. The strongest interpretation is that a substantial dwarf galaxy merged with the young Milky Way roughly 8 to 11 billion years ago. The collision helped build the interstellar halo and heated the galaxy's early disk. Could that impact have redirected the disk by almost 90 degrees? In principle, yes. Every orbit carries angular momentum. An emerging galaxy brings in its own. If the incoming system arrives on a strongly tilted orbit, its gravity can torque the gas and stars in the larger galaxy. Gas is especially important because it can collide, lose energy, settle into a new plane, and form a new generation of stars. Over time, the disk that survives can point somewhere very different from the older one. Computer simulations of galaxy formation show that these spin flips can happen, particularly during the chaotic era when young galaxies were still swallowing companions and drawing in gas from different directions. But a simulation showing that something can happen is not proof that it happened here. The proposed 90-degree figure depends on reconstructing incomplete evidence, the ages, chemical makeup, and three-dimensional motions of ancient stars. Different assumptions about the merger's mass, orbit, timing, and the Milky Way's original disk can change the result. So this is a compelling hypothesis, not a finished case. Other forces may have contributed. The Milky Way has consumed several smaller galaxies, not just Gaia Sausage Enceladus. It has also been fed for billions of years by gas flowing along the cosmic web. Each event can add a little angular momentum in a new direction. Later encounters, including the ongoing gravitational relationship with the Large Magellanic Cloud, can disturb the outer halo and warp the disk. A huge apparent flip may therefore be the accumulated result of many gravitational nudges, rather than one cinematic impact. Why should we care about a change that happened before the Sun existed? Because it changes the Milky Way from a static backdrop into an evolving system. Major mergers influence where stars form, how thick a galaxy's disk becomes, and how dark matter is distributed around it. They may even affect the local mix and motion of dark matter passing through our part of the galaxy, which matters for experiments trying to detect dark matter on Earth. Understanding our galaxy's past is a way of testing how galaxies everywhere grow. Gaia's future data releases and better models will test whether the early Milky Way turned nearly sideways or whether the evidence tells a complicated story. Follow for verified cosmic mysteries and tell me, what surprises you more, the possibility that our galaxy flipped or that stars still clearly remember that collision?